All right. Hello, everyone. Welcome to the Ganymede webinar with Solugen. Very excited to present today with Mark here from Solugen a little bit about what we've been doing with them. Welcome, Mark. How's it going?
It's going well. Thanks for having me here today. I'm really excited to talk about Solugen's relationship with Ganymede and how you've made our lives easier. I do see it's like it looks like there's only 4 people connected. So there we go. Everyone's just kind of hopping in. Good stuff.
Yeah, people usually trickle in, and this will all be fully recorded. So for people
Great.
that are joining, everything will be available later on.
Very cool.
Yeah. Well, let's go ahead and jump in and welcome everyone. The session here today will be going over a little bit of what we just talked about of Ganymede and Solugen working together. Let me go ahead and share a PowerPoint here for a little bit, just so that we can go over some introductions and context on what we've done together. Cool. So for everyone here, I'm Nathan. I'm one of the co-founders of Ganymede. Prior to this, I worked at Benchling. And on the Ganymede side, primarily cover our commercial side as well as our core engineering team. And it's been a pleasure working with Mark so far on the Solugen side. Mark, if you want to give an intro to yourself.
Yeah, of course. I'm Mark Stuczynski. I'm the lead automation and data engineer for Solugen. For those in the audience who haven't heard of us, we are a biotech chemistry hybrid company out of Houston, Texas. Before coming to work with Solugen, I was also at Benchling, and before that, I worked at a wide range of pharmaceutical companies on the West Coast. So it's a really interesting career path, and if I could describe my day-to-day, I'm basically a cheerleader and librarian for scientists.
That's great. That's a great analogy, which I feel like fits pretty well, actually, in reality. For anyone who's in that role, trying to drive the science, ultimately, you're just trying to help out the scientist one way or another.
Yeah, and I'd also like to give a quick shout out to wonderful colleagues over at Ganymede. Obviously, Nathan and I have worked very closely, but none of this would have been possible without Gavin Smith, Namrata, and Megan, and also Damien to sort of see us through to all of this. And also Matco, obviously, he's the backbone of a lot of these integrations we've built.
Yeah, that's a great shout out. And thank you for recognizing that it's an awesome team. And we're very lucky to have them. And they make my life a lot easier. So kudos to them for me as well. Well, cool. I guess, Mark, could you tell us a little bit more about Solugen, what it does, a little bit more about your role and how that interacts with where Solugen is going overall?
Yeah, of course. So Solugen as a company, like I said, we're a biotech chemistry hybrid, which is a very fancy way of saying we are trying to take take common chemistries and chemicals that are produced either through very dirty means, specifically petrochemical, and finding new ways to re-engineer and produce those products with either a net zero or a negative carbon footprint. So the way this process works in practice, there's obviously a lot of R&D to help, but we get a sustainable feedstock, a high weight carbons. This is usually dextrose. We have some in-house enzymes we've engineered to process that into a wide array of MIDI molecules, which we then further synthesize using metal catalysts. So if you can think of it like a high pressure, high conversion reactor on both sides, you get the specificity for the enzymes, and you get the throughput for traditional metal catalysis. And then ultimately that comes out as product that we then sell. So we are doing a lot of really interesting things. Always happy to talk product, but that's the long and short of it.
Gotcha. And let me actually drop the screen sharing for a second to dig into that a little bit more. But I know Solugen also, we had the pleasure of visiting the Bioforge, which is basically a chemical cracking plant. So I'm curious, how does that much more industrial side overlap in terms of what you do versus more traditional R&D? It's crazy to have both of them together in a biotech.
Yeah, it's pretty wild to have your manufacturing site right next to your R&D labs. And anyone who comes and takes a tour at Solugen, you will be very much invited to go take a look at the Bioforge. It's very clean, it's very efficient. And to answer the question, sorry Nathan, I'm always excited to talk about my job.
Yeah,
it's really great to see kind of from the initial inception of an idea to producing a compound at lab scale and all the different methodologies in play to get us there, how quickly and effectively that really does scale when we move to pilot scale engineering and then out into the plant. So the stuff that comes out of the plant, we basically produce it at small scales in R&D, and then for new chemistries, those deploy, relatively quickly. I think we recently did a pivot for one of our products called GA50, which you can definitely look up if you're interested in buying some or otherwise for that process. But we, went from essentially very low carrying capacity to very high carrying capacity extremely quickly. As far as the data side of it goes, and where kind of my job comes in, is there's a lot of different data silos at Solugen that are kind of interoperable, and getting those to align in a way that is process forward and designed to save people time is kind of the crux of what I do on a day-to-day basis. So seeing the manufacturing side of the house and how that very intimately relates to what we're doing at the R&D labs is really great, and using a combination of tools and systems to consolidate that in a way that is easy to sum up a report of how long did it take to go from process design to product is really cool. And there's not really many barriers to having those conversations and getting that data together.
That makes sense. And I love how you went straight there to the ultimate thing that you're trying to solve for is how quickly you can move through the stages with something like process design all the way up to scale up manufacturing. And from what I've seen, Solugen is very masterful at that. It's not easy, and there's always hiccups, but it's pretty impressive how quickly Solugen moves through those phases. It sounds like data is a big part of that.
Data does really help drive that. If you have no data, you have no decision. If you have no decision, you have no product. And I think it's just been staggering to me going from, some of these either, very small biotechs or very large biotechs in the case of Amgen, to a non-pharmaceutical environment where people just pivot on a dime. It's hey, one of our investors or, interested parties is, wants to see if we can make this type of compound. And then we just go and we do it. It's phenomenal. Every scientist at Solugen is just, A+. And, data obviously drives a lot of those decisions. And one of the areas which I think we're going to talk about shortly is the analytical chemistry team, which does a lot of the assay development, analysis of compounds, and how data fits into that is the way we tighten these loops and getting data back to the people who need it to make no go decisions, or otherwise little tweaks and optimizations throughout. It's a busy time here at Solugen.
Yeah, I can only imagine. That's a perfect segue actually into talking a little bit about the analytical chemistry work that we did, which is the feature of our case study that we've released recently. So let me bring that up as well here. I guess to start, I would love to hear a little bit about the analytical chemistry work you do. I've listed out a few of the instruments that we work with here, particularly what sort of pain points you saw people running into, what you were looking for, and then how that ultimately led you to pick something like Ganymede.
Of course. And just for clarification, I am not quite heroic enough to be in the lab doing these analyses myself. So analytical chemistry is just phenomenal in terms of how detailed they are and how fast they go. But, the limit on a lot of these things is you need a lot of data to make an informed decision. Or if you want to do process optimization, you can't just start with an N of 3. You have to have, hundreds of samples depending on the type of process you're optimizing and all the little variables that go into it. So in terms of pain points, analytical chemistry is an extremely, extremely high throughput group, and can't be, human interaction with the data. So the primary pain point we were encountering a lot is, how best to track instrument utilization, uptime, and also how quickly we can go from getting a request for data to turning it around and giving data to the scientists that need it. So we've made a lot of progress on this using, a combination of systems, but Ganymede in particular has been, we literally 10x'd our productivity on certain sample types between capturing data that used to be lost in summary, or, the time it takes to manually analyze and transcribe data over. So these instruments that are listed here, the DOS-GIP is actually over in our fermentation team, but that's on Ganymede. The gallery is a elemental and molecular analyzer. So we do some configuration on this, and that goes into benchling through Ganymede really easily. The gallery was a really big win in particular because it's an instrument that's very easy to use. So it's designed to be walk-up. And once we got Ganymede cooking on that, it became, we went from about 100 samples logged a month, or a week rather, to 700 in a couple days. Like the throughput increase was insane, and the level of granularity we got out of it was a lot higher. Then with the ICP, we have a few very key experts on this instrument. For those of you who haven't worked with an ICP before, it effectively is like a metal composition analysis. Everyone knows what an HPLC does, so I'll skip that one. But effectively, we had an SME whose job was to design methods, run samples, record those samples, and then transfer that sample data into, one of many spreadsheets. And once we connected it through Ganymede, it became really almost trivial to report samples, right in the minute they were done. So the throughput increase was, extremely, extremely effective. It saved the scientists a lot of time, and it saved everyone who's waiting on that data, as much, if not more, to just kind of go and see it when it's ready. So the pain points are, in summary, machines do things a lot faster than people. And if we have to have the people catch up to the machines, that's obviously a huge bottleneck versus, having machines operate at machine speed.
Yeah, that makes a ton of sense. And it's funny, one of the things I always remark on going to conferences like SLAS, the Lab Automation Conference, is that over time, over the last 5 years, it feels like all those automation conferences have actually become data connectivity conferences, because you can get to the point where you have the machines built out on the analytical side, or people will invest in work cells and liquid handlers when they can scale stuff up in terms of the actual aliquoting and so on. But then you get to the point where the data is the bottleneck. And like you're saying, these instruments are really high throughput, and the team is really high throughput. And so all of the friction that remains ends up being the data friction. That seems like a common theme.
Absolutely. And I think one key example of that is actually with the bioreactors. Everyone loves to have 19,000 data points to graph and do some studies with. No one I've found that, no one I've met at least has the desire to do that by hand for 19,000 data points. So once you connect the instruments correctly, it does kind of all fall into place. And that friction, it is about reducing the friction between instrument and human, and on both sides of like making it easy to use, and also making the data that comes out of it easy to parse and, get what you need quickly, versus having to, extract from a weird file format, convert that, throw into Excel, do some graphing, destroy your outliers, send it over to Jump, all that unfun stuff.
Yeah. And I think that's a perfect description of, we have a sort of a before and after description here. And from what we saw, it's exactly that. Every single step of the data movement is manual, and you're really using people as the pipes, and then you're not capturing data centrally. It sounds like that's the square on here.
Exactly. And I think the way I've always articulated this to, a lot of other people who are, bench scientists first, is data engineering's role at any organization is to make it so you can do the things that you want to be doing more often and better. And a good example of that in a little bit more coarse language is, no one wakes up at 6 years old so they can go, manipulate things in Excel. You want to go be a scientist so you can go to the bench and see what you do and come up with great ideas. And the Ganymede has made my life a lot easier, and it's made the scientist's life a lot easier to that effect. Because, like you can see here, everyone's done an issue when you've done a big block of Control C, Control V. You skip a decimal, you put a decimal in the wrong place, God forbid, pick the cell wrong when you're doing, some complex curve fitting formula. And if you look at the, before state, it really was a request comes in through some method. It, a human goes over to the machine, says, this is sample X from person Y. Who knows if it actually is that? Who knows what the barcode or sample ID is? Instrument puts out data. You got to filter that. So you add, did this work? Did this not work? Send it back to the person. They do some analysis. The process is very error prone. And, like I said, everyone wakes up to go do your lab experiments, maybe not so much transcribing things into Excel. And so Ganymede really smooths this over, which I hope you have another slide for right after. I have a feeling about it.
I do.
Cool.
Yeah. And I think this is a perfect use case, because you can see you understand the data pain point that exists at every step here. And that's exactly the motivation that caused us to create Ganymede, was saying these systems are all great, but they need to connect together, because if you're having people have all this rich data, very high scale data, doing many analyses across many samples, that creates a humongous data burden for people in terms of just data entry and data movement. And so I love, this is the exact realization of what we wanted to do when we launched years ago, to be able to speed folks up like Solugen and get that to that 10x sample throughput point. It's really impressive.
Yeah, and I think analytical chemistry is obviously a really interesting use case, but what this does show is when you're doing enzyme engineering or metal catalysis engineering, every data point matters, but not every data point matters equally. Solugen's really data forward in the sense that we have a very good set of machine learning engineers who need to take this data and make something useful from it. Anyone who's kind of touched the machine learning space knows that curated, clean data is essential to making something that's not garbage in, garbage out, and making it so Ganymede enables us to take data directly from instruments and pipe it to the teams that need it for and also to fit into their models as seamlessly as part of a process block in our overall workflow. And nowhere is that more evident than, we 10x sample throughput from both from hey, this is data we weren't capturing before and now we are, and also the time to value for how we generate that data. So when we're talking about it, it's both, we had a huge gain in the amount of work we were able to accomplish in the same time frame, but also the quality of that data went way, way, way up. And when we're going into these enzyme engineering campaigns, you might be screening hundreds of thousands of clone variants, and without an automated system that lets you do the liquid handling, that does the analysis once you put it through some kind of spectroscopy, it's really hard to get anything meaningful out of that. So our Databricks system is kind of the backbone of all of our data architecture. Really, that's where all the data from whether it's coming from the plant, quality, product, R&D, it goes back through there through various pipes, and Ganymede also helps us manage that really effectively. So for the scientist, hey, you don't have to go transcribe a bunch of Excel sheets. And for the data and machine learning engineers, the data you get is pre-qualified, which is really nice.
Yeah, and I know this slide is a little bit busy, but I think it's worth emphasizing exactly what you just said, which is that this really removes almost every human element required, ideally. The only thing that the scientist should be having to do is think scientifically and saying, okay, well, what are the configurations I'm running?
Exactly. You set up the method.
All these human input points are gone.
Yeah, you set up the method, you take the sample, you apply it under the right conditions, and you get your data out. You don't get that data out to a paper notebook, you get it out to your lab notebook, and it should just be there for you ready to go. And this really does enable us to do this. I do think it's really worth sorry to interrupt, Nathan, but I do think it's really worth emphasizing, on a per instrument basis, this adds up really quickly. With the ICP, we do about 10 runs a week, and the overall throughput time decreased from 150 minutes of parsing data to under 15. And you average that out for one FTE, that's 22 FTE hours a week back. And then if there's multiple people using multiple instruments, you can kind of imagine the value that drives. So just by not 100%. Copying and pasting things.
It's pretty crazy the amount of scientist time that goes into that, because one of the things I've always said to people and experience myself, which is why I say it, is if you actually follow the scientists around during the day and see what they're doing, so much of it is messing around with files and data and trying to get the data formatted right and things like that. And all the different elements of this that are now captured in the blue Ganymede components here are things that previously would have to be human pieces of this. Because it really should be, the dream is to get to the point where you say, yeah, all I have to do is design my experiment and then go physically move the samples around if needed. Maybe one day there can be perfect robotics for that too. But then you just design your experiment and run it, and then the data is out there. And ideally, the analysis can be automated too. And so, this is a really great, the high scale use case is great.
And another kind of subtlety on this is, that just occurs to me is for those of us who are in, kind of quality adjacent spaces, you don't have to be full GLP, but it helps sometimes. Ganymede in particular is really useful for maintaining not only a record of the data that's actually being produced and sent on to the notebook, but also the actual operations on that data itself. So for instance, we all have a really great scientist who works in the lab who's extremely skilled at scripting and, Python, or, it's kind of hard to maintain what version of the code it is, what the code looks like. And Ganymede does give us that extra layer of confidence in, hey, this is the way we did process this data. So instead of it being kind of on, with the best of good faith, someone did this calculation right in Excel, it does give us that extra level of security that like we have an operational process that is right here, it's documented, and we can see both the raw data and the transfer data. And I think closing that loop makes it very easy to convince an auditor that like, hey, this time-saving process is a quality increasing process as well.
Yeah, I like that because there's basically, we think about the value that we can deliver in three ways. One is scientist time savings, one is data quality, and then one is giving this rich data layer to data science to hopefully derive scientific insights too. And the latter two, the data quality and the scientific insights, are ultimately probably some of those powerful pieces of this. But one of the things that we found, and you can appreciate this definitely because of we both been at places like Benchling to understand this from the scientist ground up, is you can't really quantify the scientific value of the scientific insights. It's hard to quantify value and quality. So you want to get there, but the best way to sell it is through time savings and helping the scientists at once. So it all seems to go together here in a really nice way. Those three layers, and the scientist value proves it out quickly in the early days.
Absolutely.
Awesome. I guess on that note, I would be curious, kind of moving the data strategy side, and let me also drop the screen share again a little bit so we can show our faces on here.
Of course.
What are you thinking as some of the next steps for you in terms of your data strategy on the Solugen side, like different areas that you want to get into, different modalities of what you want to do with the data? And I will note real quickly before you jump into that, I'm also going to release a poll to everyone on the audience here around which instruments are your most painful instruments. So we'll review the results of that at the end.
If you're not answering HPLC, I'd love to talk further about why yours are so good. So I guess in terms of data strategy from where we are to where we go, I think data is one of those things that everyone really wants, but no one really kind of emphasizes until there's there's an event that precipitates it, right? So I think Solugen is really unique in the regard that we are really data forward, in the sense like we're thinking about things from systems level data and how we run experiments to how we produce samples. It's all systematized, organized, and where we want to go next is really making it easier to connect and operationalize that, which is a lot of buzzwords basically say we're all doing things that are like good data policy, but in terms of like unifying it and making it to a centralized data store, that's really where we're moving towards. So right now we have our R&D systems connected to Databricks, we have our finance systems connected to Databricks, and that's kind of cool to see like, hey, every time you press this pipette plunger, you're spending X amount of money, if you kind of want to break it down that way. But I think the next steps for us are, we've obviously got really good policies in play across Solugen as an org. It's really about tying all those things together and having interoperability from point A to point Z. So we all know Alcoa for is it attributable, is it legible, contemporaneous, original, and accurate. And right now, the biggest thing is consolidating data from different sources in ways that we can parallelize and not have to kind of consult individual SMEs to be like, hey, what happened over the course of the last 3 months in the large scale bioreactors compared to the small? Like consolidating and organizing that data is really where we're going next. And I think the best way to do that is just, it's not about practice in a lot of ways. It's just about building good systems that people, feel comfortable with. I'd actually love to hear from you, like what kind of strategic bottlenecks, other folks using Ganymede might be running into. Because I think for us, Ganymede is solving the issue of we use a lot of instrumentation to manage the throughput, to manage the data, and kind of streamlining that part makes the data quality go up, and it makes the speed and time to value go down, which is nice.
Yeah, it's funny that you mentioned some of the notions of comparing like small bioreactors to large bioreactors, because I feel like that's one of the things, I guess, going back to that notion of we want to provide scientist value and automation to save time at the start, but then what is the scientific insight that can be derived on top of that? I think it really comes down to cross-run comparison, and that's something that has been interesting to see how poorly designed a lot of the instruments and workflows that people do in biopharma are. If you all the time, and even our very first clients used to always say like, hey, I wish I could compare my bioreactor runs over time or between instruments. I can't just query for like what was the highest titer or pH that I've ever had. It's a simple query, but like just can't compare the runs. So I feel like that's definitely a really common theme, and it sounds like you're running into that.
Yeah, I think when it events or kind of like overall data structure, we've got a very strong data model at Solugen, which I think, is something I'm personally very proud of as the data architect who built it. But it's also a matter of, if instruments output files in different formats, there is some sort of reconciliation that goes on there. And, the less I have to manually edit Excel sheets, the happier I am as a person. But also, yeah, I think that's definitely a huge bottleneck for us as well.
Yeah, and on that side, I think we see a lot of that cross-run comparison issue, and more just generally, there's no metadata that's attached to everything. I think one of the other bottlenecks that I think people run into that we also work a lot with people on is being able to actually leverage the data structures that they build out in their ELN or LIMS across more things. I guess it's related to that notion of comparing runs, but being able to say, hey, I spent all this time building out this data structure in something like Benchling in your case for batches and parameters and configurations and things. And then that's within Benchling, but the raw data is not attached to it. It's not threaded through further. And so
exactly,
that
there's a break in the chain.
It.
Yeah, and I think like on the subject of benchling in particular, I think benchling is a very useful ELN. I think the LIMS capabilities are, very helpful to avoid data fragmentation. Like you said, it's hard to compare runs when they look completely different. Like, we both know that, apples and grapes are both fruit, but it's kind of hard to say, it is literally the apples and oranges comparison, right? So I think also being able to automate and combine these systems means it gets people thinking about things in a way that is very data forward, in the sense of like, not only what am I doing, but why am I doing it? Like, what are the key pieces of data I want to extract from this? And also like the supporting evidence for it. And kind of leveraging automation and integrations with Ganymede enables you to do that. But I also think that it is really beholden to a data strategy that does like really think about like, this is why this sample has these requirements for it. This is why we record data in this way, versus like the machine's just going to spit out whatever is easiest for the machine. And kind of getting out ahead of that and putting a little bit more nuance to it is definitely an area we're really focused on at Solugen as well.
Yeah, there's it's funny, I guess another conference callback, because I live in conferences. That's everything in my head. You see oftentimes at data conferences, people are all busy building out digital twins of their process at the large scale manufacturing side.
Right.
And on the one hand, I love that. But on the other hand, then I'm like, well, that's not how the rest of the world works. The rest of the world, you design your process in software. Software has kind of eaten it the way that people talk about software eating the world. And so it's more like you would design your process in software and then build the physical twin to actually suit it.
Right.
And I wish more people thought about their labs that way, of saying, let's define the data structure of the process. Like, what assay are you doing? It's input data and output data.
Right.
And then you actually go implement it.
I think that's like something where, Ganymede describes a lot of the infrastructure you guys build as the lab as code. And I think that's like very telling. As someone who really did start at the bench and kind of moved more into this like data and software space, I do think it is sometimes really interesting to see where something that on paper or on computer is a really easy connection from A to B is actually a lot more nuanced at the bench. So, such that like my favorite use case for this is at Amgen in our LIMS system. Whenever you did a split of your cells to scale them up, it was a different event in the LIMS system, which on face value sounds like really easy, right? Like you just click a button, you multiply it by n times and you're good to go. But in reality, it's like there's a lot that actually goes into that type of record keeping. So when it comes to building these digital twins, it's not only about maintaining accuracy, but it's also about maintaining flexibility and ease of use. So that's something that I think I'd really recommend be a very big conversation topic between the data engineering IT folks in the room, as well as the scientists, to say like, hey, we all want to record the data in ways that make sense, and both sides have a very valid input to that. But it does need to be done in a way that it's like, frankly, someone's not going to go around the system. You have to make the system sticky. And the best way to do that is to make it, intuitive for the users. And that requires a lot of cooperation. I never view like the lab as code or the data architecture as fundamentally that removed from what's happening physically, even if it's like a lot easier to say like, yeah, there's this one parent entity that has these child entities that are in turn parents of these child entities that are in turn of this like fourth type. It's, because that's how it works in biology, right? Like once you split a cell, it's the strain engineering workflow is always really novel in that regard, and that like sometimes it's an isolate, sometimes it's a strain, but they're physically the same thing, right? So you gotta really wrap that process in too.
Yeah, and I think increasingly it seems like people are starting to get that you have to be thinking that process centric, kind of describing the process in data structure from the get go. It seems like the thing to do nowadays, which is great because that's what we need to accelerate stuff.
A metaphor I heard kind of, one about, bench work for the most part is you can tell very quickly who the people are in the sciences who played a lot of video games when they're growing up, and like who like really got into like the crafting system of things, because it's really about, it's less about the individual results and more about like the modular components that fit together. It's like, it's not just this string, you slaved for months and months to screen the cell line. That's obviously very cool, but that cell line in turn is a input to another process. And thinking of it, again, like you were saying, as inputs, outputs, and kind of the key pieces that go along that seems to click with certain people more than it does others, but it doesn't diminish the fact that like, hey, this is the data we need to move forward, but it's also the data that represents, the best outcomes of what you were doing in the lab. Data is the easiest way to make a mark that like what you did actually happened, is the way I like to think of it, because if you don't, record your data, it's like it never existed in the first place.
Music to my ears.
I would think that, yeah.
Cool. Well, I guess before we kind of wrap up here and then switch over to audience questions, maybe one more question from me is, what are you excited about in the industry? Maybe in your work in Solugen on the data side, or just in general in biopharma?
Yeah. Well, actually, I'll flip that on you. Like, you tell me first, like, what's exciting, what's keeping you up at night in a good way, not a horrified existential way? Like, what are you seeing? Because you're seeing a lot more of it than I am at this point, because I'm very, dialed in on, Solugen stuff.
Fair. It's kind of like a broad, but not as deep view. But one thing I think that we're really excited about is finally actually starting to see more scientists who can code come through. I think there's a lot of scientists who can code very well and are very smart, but they spend most of their time historically, it seems like, on bioinformatics and omics workflows. And so in a way, when we were starting Ganymede, we originally were expecting, all these folks working on bioinformatics will come in and automate their lab, but it's such a different discipline. It almost kind of sucks the air out of the room when it comes to wet lab automation. And then you end up with dry lab versus wet lab. And people become very separated there.
Right.
But now I see, especially with some of our partners that are really overtly saying, this is the way that the world has to work. We've got to get to the point where people have data literacy. Maybe they're literally coding, or maybe, like you said, they're people who kind of appreciate the crafting systems and get structured data, even if they're not in code. It's the same thing ultimately. And we're starting to see that where people are using Ganymede self-service more. And that's our dream, is to say, we want to be this infrastructure to build your lab and code. We want to be this infrastructure to move around and capture data with your instruments. So
we've done a little bit of that at Solugen for what it's worth.
Yeah.
So very useful tool. Yeah, as far as stuff that I'm really excited about in the data world is we obviously have this big machine learning push that we're doing over engineered enzymes and, all the strains that came out of it. That in turn is fed by some algorithmic work we're doing to, avoid making hundreds of thousands of weird, DNA sequences and saving us time and money on that as well. So I think that's a big focus for me in the next couple of months, is just really making sure that like our machine learning teams can access this treasure trove of what we're doing in lab and be able to maintain, throughput and scalability. Scalability is everyone's favorite S word, because it's like, it's great if your thing works with an N of 1, does it work with an N of 5,000? Because that's, really the open question. So I think for me, it's being able to say like, yes, you don't have to do this thing, this repetitive task a million times to get to the data point you want is, really exciting for me. Like I said, I'm a big cheerleader for scientists. I'm a big librarian. I think for me, the biggest thing is, at the end of the day, if I go home and I save someone time, that's the best resource I can give back to someone.
Yeah, same. I mean, that's why we're here. So
exactly.
Definitely appreciate that.
Cool.
Awesome. Well, I will share a couple more slides just to kind of round out some of the discussion that we've had here. And then we'll switch over to audience questions. if anyone has questions, please feel free to throw those in the chat. There's a little question section, and we'll pick those up in a few minutes. But so there's a couple of key concepts I want to quickly go over that we love, that I think hopefully this presentation has given people a good feeling for, which is that ultimately automation of the data and helping the scientists accelerate their day, we think that is the best way to also scale up the data capture and build better data quality. People have done a great job moving on to off of paper and into electronic systems, and that's great. But oftentimes that means people are doing even more and more data capture, and you're actually potentially taking more time recording data than before as these systems scale up. And so as the process matures, people are doing even more data entry. But through automation and through moving the data around, we see that actually declining. And so that's where we say, you can't just do a digital transformation or some data lake initiative in isolation. It can't just be for data scientists. It has to involve the scientists. Right. And it has to drive value to them, and that'll help. It'll build a richer data set.
I think, that really, I really do see this a lot. And I think the driving question I have is like, in general, whenever we build like a new schema or new form for data ingest, like what are the things that actually matter here? Because we can have, a slightly variant version of a process. Is there maybe a better way to harmonize and represent that? Or are these like values truly and wholly unique? And I think for me, it's, like you say, the ability to capture all this data is great, but the so what of it is how do you make use of it? And if it's just kind of going into a file store somewhere and that's it, then, does it really matter that much? And I like this idea of automation fundamentally helping you piece out the data that you really care about and need from the process, rather than it just being like, the ICP spits out, 500 columns, but you need 3 of them. So do you parse 500 columns? No, you take the 3 that matter. And, but if we needed those 500, it would be a lot easier to do that than, copying and pasting it.
Yeah, I like sometimes when people talk about the data lake, I say, well, a lot of these data lakes, they become data swamps because if you just dump the data in there without context and without sort of curation behind it, it's going to be useless.
And that's, why we personally use Databricks. I think Snowflake is another really good example of, systems designed to, align and do delta over these things of like, hey, is this thing really unique, or is this something that we've done? And, having more transparency and structure around that data is really key. And kind of on that note, we prefer to call it the data bayou at Solugen because we're down in Houston.
I love it. At least the bayou is navigable, hopefully.
True. I've also heard the term data lake house, and that's always people have fun in this industry.
Yeah. Well, and I guess for us also, so we definitely store a lot of data and try to also help people build their data lakes, whether they store it in Ganymede or put it into a data infrastructure system like a Snowflake or Databricks or even just S3 buckets or things like that. But we always are big advocates. Another theme, hopefully, which came through in the presentation here, is building up towards those higher level insights and saying you have to walk before you run. You have to actually you have to have good usage of an ELN or a LIMS, and you have to actually capture your data from the instruments systematically and not just be dumping it into folders. Before then you can do automation, because now you can actually connect the data together, and that builds the foundation for insights. It sounds like that's something that you also definitely have seen.
It's definitely something I encountered both, working across the breadth of companies at Benchling, and then, with the depth at Solugen of like everyone, I think as scientists and engineers, we all have a good sense of like what good data looks like and what good practice looks like. The only problem is when you go to hand that data to someone else, if there's not like conventions or shorthand, it becomes very, very much more difficult to parse like what's actually happening upstream. For instance, like in our case, obviously we do enzymatic reactions before we do heterogeneous catalysis, and the enzyme we use has an impact on how that catalyst performs. So, but it's very hard to find a scientist who's got a PhD in this inorganic chemistry and also a PhD level understanding in the biochemistry involved, if that person exists at all. So I think, what you're getting at here is data structure and, data alignment really is kind of the Rosetta Stone between how different departments speak to each other. And, even something as simple as like, flipping columns, maybe like tighter first, maybe like VCD second, maybe like VCD first, tighter second. But, that's obviously an easier comparison to make than, if you had to go down to the, metals chemistry group and be like, hey, so this is what we got out of our enzyme reactor. They'll be like, oh, so like how much of it is this thing and how much of it's this thing? And, the questions and answers you have are very different if you don't follow kind of some sort of convention that takes you from A to Z. Which is why data engineers are actually, I think, very important, because it's like I said, it's about being a librarian. It's not to like hoard knowledge and make it hard for people to find, as much as just like, hey, you guys both have a problem you're trying to solve. How do we make them solve together by being a relatively removed observer and not just saying, oh, metals team, you're going to do the biology method, biology team, you're going to do the metals method, right?
Yeah, and it's like a lot of software engineering, and you're talking, it really sounds like about data products. And same with software engineering, you're building out products and trying to solve problems. You're not just going into the data blindly. You're trying to say, okay, what are these people actually needing at the end of the day that data can help them with?
Exactly. So,
awesome.
And I think Ganymede's been tremendously effective at helping us kind of sort some of that out too. Just, if it's Ganymede's, data store, that's obviously a lot more preferable to me than if it's like someone took this Excel sheet and went and put it in some Dropbox folder, but that folder is structured differently than how this other team is doing it. So, the more uniformity we can do, the happier I am without losing, the critical insight, because it's the differences in where the, advantage and discovery lies.
Yeah, I like that framing. That's probably a good nugget to leave people with, trying to figure out, where do you move next? What can data help you do? So I love that.
Definitely.
Cool. Well, thank you so much for everyone here. If anyone ever has any questions for Ganymede or for Mark, we're more than happy to connect you all and share perspectives. Please reach out to us at hello@ganymede.bio or hit up our website at www.ganymede.bio. We'll take a few audience questions before we break here, if anyone has any questions. And we have questions hooked up both from chat here and from LinkedIn.
Great. Yeah, please. And please, ask me anything. Happy to talk about all kinds of stuff.
Awesome. And actually, I should reveal the results of the poll. You won, Mark. It's 50% chromatography and then a bunch of other stuff. But it's definitely the chromatography stuff. But we love working on that, so good.
Yeah, it's we like the chromatography stuff we're getting with Ganymede. So I'd say you guys are doing a great job.
Awesome. Yeah, much appreciated. I guess going through some of the LinkedIn questions, one for us, does Ganymede run on the cloud? Ganymede is a fully managed SaaS product, and so Ganymede is able to run independently. You don't have to administer everything. We run natively on GCP, but can also work with AWS, Azure, etc. And so it's pretty flexible in terms of the infrastructure people run on, but our goal is to be that infrastructure so people don't have to manage it. Question for Mark. How do you know that this was the right timing to do a project like this?
I think so there's like a little bit more of a polite answer, but I'm going to give you the direct answer. And it's like, the direct answer is it's always the right time. Anything you can do to save people, time, energy, and effort is always the right time. As far as like, I guess to be a little less snarky with that answer and give a more direct one, the reason why we pursued Ganymede now is mostly because we hit that point where we're reaching the digital maturity we need to avoid discrepancies in how people are recording and structuring data. It's not so much like, this team does Excel sheets over here on their laptops, this one does it in Dropbox. Once you get past that first bottleneck of like, hey, we have a data strategy, you can really kind of help adoption with that and accelerate time to value by taking on these automation initiatives. Plus, like when, you look at your P&L sheets or you're just kind of determining costs, scientists are expensive and you want them spending their time doing science, not something that, you can automate. So if Ganymede, saves you multiple FTEs worth of work for less than multiple FTEs worth of cost, that seems like always an on balance positive thing to me. And that's why we personally started to pursue it, is we had that basic digital maturity and also that like urgent financial need to justify doing these initiatives.
Yeah, that makes a lot of sense. It kind of resonates with, as for us as we grow, there's all these questions that we always ask around, like, when is the best time to do webinars,
Right.
for instance, in the week? And, sure, yes, 2 p.m. Eastern on a Thursday is a pretty good time. But if you read any statistics, the answer is just always do it, because it's harder to just go do it and set it up than it is to overly precisely pick a time. And I feel like the same principle applies to really any project like that. Like, it's never too early to think about data structure. And we've seen huge dividends come to people from thinking about that early.
Yeah, you don't have to be perfect on the first swing, but if you don't take any swings at all, you're going to be sitting there while the ball goes by. Sorry for the convoluted baseball analogy. That's just kind of what you get with me.
Chicago.
Yeah, exactly. So do we have anything else on LinkedIn? I do see one from Esteban in chat.
We have one more quick one. Do we connect with LabVantage? Yes, we work with pretty much every Elon LLMs out there, including LabVantage, Labware, et cetera. And always happy to talk about that. But yeah, if you want to, I think you're probably best positioned to take Esteban's question.
Absolutely. Hey, Esteban, thanks for the question. What sorts of coding projects related to lab data automation would be a good start for a scientist wanting to pivot more to the software engineering side of things? I think the fundamental programming language I would recommend is Python, just because Python will let you sort of go anywhere you need to. And as far as like the actual like process operationalizations and things like that, start with things that are really big data sets that people really don't like doing things with, and find a way to make those data sets. My first like machine learning, like lab automation thing I did was basically getting a bulk export of LIMS data on a bunch of cell lines, and then just trying to find like standardized conditions and data to see what was the best way to grow those cells quickly. Not necessarily grow them correctly, but grow them quickly. And I would just say things that let you take a bunch of like, swallow the ocean, take something that's a bunch of data and distill it down to key data points quickly in ways that would be hard to do by hand. Those are the projects I think are the highest leverage.
Yeah, I like that. It's the same principle. You provide value, try to find something that's really annoying in high scale, and automate it.
Exactly.
And definitely agreed on Python. That's why we chose Python. It's the lingua franca of science and analytics these days.
Yeah, Python's great. Highly recommend Python. Cool.
Awesome. Well, yeah, that's all the questions. If anyone has any other questions, again, always feel free to reach out to us. Reach out, hello@ganymede.bio. Happy to chat about Ganymede. I'll refer questions to Mark as well, or give a demo. But otherwise, thank you everyone for attending. Really appreciate the time.
Thanks for having me, Nathan.
Has a good rest of the summer. And thank you, Mark. Yeah, thank you for taking the time with us.
Great. All right, folks. See you around. Feel free to hit me up on LinkedIn if you have any other questions too. See you later.
Thanks, everyone.
Bye-bye.
Bye.